Okay, so for this lesson, we're going to talk about rectangles. A rectangle is a parallelogram that has right angles. Okay, it's a parallelogram that has right angles. So any property of a rectangle is going to be all the properties of a parallelogram. And that's going to be the diagonal divides the parallelogram into two congruent triangles. Opposite sides are going to be congruent. Opposite angles are going to be congruent. Diagonals will bisect each other, and consecutive angles are supplementary. So in order to prove that something is going to be a rectangle, you've got to make it a parallelogram first, and then talk about some of these right angles. So the fact that the parallelogram has right angles, all angles are right. Again, you know this already, therefore all angles are 90 degrees. Or all angles, I guess, are congruent, we should say. And the diagonals also happen to be congruent. So these are two other properties that you have in regards to rectangles. So you should be able to do some algebra stuff with it as well as proofs. So algebra, you've got this rectangle ABCD. They tell you that AR is 3 times the quantity 4x minus 3, and then DR is 10x plus 1. And then you want to find AR, CR, DR, and BR. Well, you know already that the diagonals are congruent. So I know that all of BD is congruent to all of CA. And you also know that the diagonals bisect one another. So if I'm going to cut whole equals in half, all of these parts are going to be equal. With that, then, I know for sure that AR and DR are congruent. So then what I could do is I could say 3 times 4x minus 3 is equal to 10x plus 1. And then when you distribute 12x minus 9, 10x plus 1, subtract 10x on both sides, add 9 to both sides, x comes out to be 5. They want you, though, to find all those missing pieces, AR, CR, DR, and BR. Well, all of those guys are going to all be the same, right? So AR and CR are those little halves, and then BR and DR are those little halves. So then why not plug them into one of those pieces? You can plug them into DR if you want. That's probably the easiest. So you know that AR is equal to CR, which is equal to DR, which is equal to BR, which if I just plug this in here, 10 times 5 plus 1, it's all equal to 51. Same triangle. AC is 3 times the quantity x plus 2x plus 5, blah, 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 and then BD is all this stuff. They want you to find x and find AC and DR. Well, AC is the entire diagonal. BD is the entire diagonal. The fact that we know we're in a rectangle, we know that diagonals are congruent. So here's some algebra for you. We're going to say that 3 times 2x plus 5 minus 1/4, 4x plus 4 is equal to 2/3 12x minus 3 plus 5x. Distribute. 6x plus 15, 1/4 of 4x is minus 1x, 1/4 of 4 minus 1 is going to be equal to 2/3 of 12. 12 divided by 3 is 4, times 2 is 8. 8x minus 3 divided by 3 is 1, times 2 is 2, plus 5x. So hopefully you know your fractions. On the left-hand side, you really have 5x plus 14. On the right-hand side, you really have 13x minus 2. Subtract 5x from both sides, 8x. Add 2 to both sides, get 16. Divide by 8. And then you get 2 is equal to x. All that's left is to plug in 2 into either side. You pick and choose which one you want. And once you plug in 2, you're going to come up with AC, which is equal to BD, is going to be equal to 20. Hold on. So AC, which is equal to BD, is equal to 20. Is equal to 24. And then they also want you to find what DR is, and DR is just half of AC, so DR is 12. Okay, so now we get into the proofs. Proofs. So we're dealing with quadrilaterals. To prove a quadrilateral is a rectangle, use any one of these following, okay? So you could probably even use other methods too, but one of the most ones that happen most often is prove it's a parallelogram that has one right angle. Okay, that's like the definition. You can prove it's a parallelogram, but it's got congruent diagonals, because that's an extra property of a rectangle. Or you could also prove this thing being equiangular. So if you prove that a quadrilateral is equiangular, that means all the angles are the same measure. They all have to be 90 degrees. And then it could be a rectangle or a square, but it's enough to get it to be a rectangle. So we want to, we've got that right triangle ABC with right angle ABC. So here's the proof. We know this is a right triangle, and we know that this is the right angle that's in the picture. Okay, we know BE is a median. Well, a median of a triangle creates a midpoint. A midpoint is going to create two congruent pieces. And we also know that BE and ED are the same. So we also know that BE and ED are the same. Somehow we've got to get this thing to be a rectangle. Okay, well, we know that once all this happens, these diagonals bisect each other. If the diagonals bisect each other, you have a parallelogram. If you've got a parallelogram that's got a right angle, you have a rectangle. So we have everything we need. Let's just put this down into words. So here's where we're going to start. Number one, we've got right triangle ABC with right angle ABC, and that's given to us. I'm going to probably put my givens in different lines. You can put them all in the same if you want. It doesn't matter. You are also told that BE is a median. Okay, so this is given to you. Well, because a median is a line segment that goes from the vertex to the midpoint of the opposite side, we now know that E is a midpoint of AC. And that's just because we know what the definition of a median is. Okay? Well, the fact that we have a midpoint, we can now say, and the midpoints of AC, we can now say that AE and EC are congruent. And that's because of definition of a midpoint. We also were given that BE and ED are congruent. So this was given. And then we also said that, well, if that's the case, these diagonals are bisecting each other. So then we know for sure that ABCD is a parallelogram because if diagonals or I guess a parallelogram, a p-gram has diagonals, and you can write this in any way you want, that bisects each other. You don't have to write it the same way that I'm writing it, but somehow you can say if the diagonals bisect each other, it's a p-gram. Again, I'm not picky on that. You can figure that out. And the fact that we've got a parallelogram and we already had a right angle, we know for sure that ABCD is a rectangle. And then this reason is a rectangle is a p-gram with one right angle. Okay, so let's see if you can digest that. We've got the right angle, we've got a median, the median gives us a midpoint. A midpoint cuts a segment into halves. We had the other segment that was cut into halves, which happens to be a diagonal. So those things are bisecting each other. Once they bisect each other, you know it's a parallelogram, and a parallelogram that has a right angle is a rectangle. Let's try this next one. Okay. this and then this. Alrighty. Let me just bring this down for a second so you can see this picture. Okay. Hello. Up. Up. Okay. So we're given a parallelogram again, ABCD, and we know that AC and BD are congruent. That's enough to tell you have a rectangle. I get it. If the diagonals are congruent, it's a rectangle. But I want you to be able to use other properties, not what we know, to find out why you have a right angle. So we're not using givens as reasons to prove this thing has a right angle. So what can we possibly do? Well, we've got these sides being congruent, or these diagonals being congruent. I bet you we could probably get congruent triangles, and that might be enough to get us into getting a right angle, because if we've got a parallelogram, make sure that you're good with this. Parallelograms have opposite sides the same, right? Well, they're telling you that the whole diagonals are the same. So if you think about breaking out these triangles like this becomes BAD, this becomes CDA. These end up being opposite sides. These end up being given. This guy down here is reflexive. You've got triangles congruent by SAS. I'm sorry, by SSS. And if the triangles are congruent by SSS, then these guys have to be congruent too. Well, if I were to go to the big triangle and I say that these two angles are congruent, in a parallelogram, consecutive angles are supplementary. Well, if angles are supplementary and congruent, the angles have to be 90 degrees. BAD must be a right angle. So maybe try to talk through it first and then write it out. So here's the write out for this thing. Okay, first step. We've got P-gram ABC, D with what? With AC congruent to BD. And that was given to you. Okay? That's all they're giving us. But we know that BA and CD are congruent. And the reason for that is opposite sides of a P-gram are congruent. Okay? So that's two pairs of sides. We know that AD is congruent to itself. And the reason why we know this is because it's reflexive. Maybe you say AD is congruent to DA because when the corresponding sides match up, that's how it's going to be. I'll take it like this for now. I'm not so worried about the letters except when we get the triangles down. So now we know that triangle BAD is congruent to triangle CDA. And this is because of side, side, side. Well, the angle that they have in question, BAD, we know is congruent to angle CDA. So angle BAD is congruent to angle CDA. The reason for this is corresponding parts of congruent triangles are congruent. And now you got to think again, this is where we went before. Well, we've got a parallelogram, we know that already. We've got these angles that are consecutive angles congruent in a parallelogram. And we know that if they're consecutive angles, they're supplementary. So we know also that BAD and angle CDA are supplements, or supplementary, I guess is probably better. Because the property that says consecutive angles of a P-gram are supplementary. And then what we can finally say is, all right, well, if those guys are supplementary and those guys are congruent, then we have to know that angle BAD is a right angle. And for that reason that we just said, congruent angles that are both, let's do it this way, angles that are congruent and supplementary are right angles. All right, let's try to digest this guy too. Okay, let's see if I can move this. I don't know that I can. Can I move this? No, that's okay. So we've got the parallelogram with those diagonals being congruent. We know we're a rectangle already, but we're not using that. We also know that the opposite sides of a parallelogram are congruent. That's the BA and the CD. AD is reflexive. We've got congruent triangles by side, side, side. We've got congruent angles by CPCTC. Those congruent angles are consecutive angles, so they have to be supplementary because it's a parallelogram. And any angles that are both congruent and supplementary have to be 90. Alrighty, that's it. Good luck.